Hello there and welcome to day 29 of 30 Pandas Library Challenge. My name is Valentine and I'll be your instructor. To get started with this Pandas Challenge where we get to explore various data analysis concepts, you need to visit the description section of this video and click on the practice resource link. That should take you to a page that looks like what you're seeing on the screen. Once you get here, click on the sample resource. That will prompt you to sign in and just say continue learning and you should get to the sample notebook. Once you get here, go to file, then save a copy of this notebook so that you can be able to reference it or use it in the future. But yeah, that's what we're going to be using. I am going to be using the practice notebook, which is similar to the sample notebook. The only difference is that there are more challenges in the practice notebook, and Afterwork members also get access to the practice notebook. Okay, so let's get started. The first thing that we need to do is to actually import the Pandas library because that's the library we're using for this particular session. And then we can get started with the first concept. In some situations where we are working on certain research questions, we might need to write custom functions using Pandas. And within those custom functions, we might want to execute some query methods to filter for data. So for example, if we had this data set that contains credit card transactions, which you can see, we might want to filter for transactions. The transactions maybe that contain amount greater than a certain value that has been given as an input. So the first thing that we would need to do is to define a filter filter transaction function. So this is the function, the custom function that we have. It will take in some input, and then inside it we would return the results of the query method that we want. So in our case over here, we are just giving this function an input, which could be a number. In our case, it's in relation to what we want to test within our condition. So if the amount is greater than the amount that has been given as an input in the function, then the records for that contain that amount greater than what we have specified would be returned. And then here we're just calling the function and passing the value that we want greater than 200, and we can then filter the data. So all these records have amount greater than 200. All right, pause the video and then work on the challenge. Moving on, in some situations, we might want to convert automatically columns, and we might want them to have some specific, not even specific, just data types, appropriate data types automatically. So what we can do, we can initially, first of all, determine the data types for the data set that we are working for. So this is how we do that. We use the dtypes property, and we get the data types for each column. And then we use the infer objects function. We apply it to the original data frame, and that should give us the data types in the appropriate format. This is just an example. We may not necessarily have, in this case, we don't have a data set that allows you to see a conversion specifically, but this is the technique that one would end up using. All right, pause the video and then work on the challenge. Moving on, in some other situations, we might want to select specific columns that have a data type that we might be interested in, which would be efficient, especially when we have lots of data. So if you have hundreds of columns and you want to work with only columns that have maybe int 64, then we can use the select dtypes function to specify the data type that we want. So if again, this is the data frame that we have that contains transactions in relation to credit cards, then we can apply the select dtypes function to the data frame, and we specify the data types that we want as the value. We specify those data types inside a Python list, and we pass that Python list as a value for the include parameter for the select dtypes function. And we store our outcome in selected columns. And this is what we have. We have the columns that contain float 64 as well as int 64. So either of these ones. So like you can see int 64, it's the transaction ID, and float is now the amount ID. We don't have any other column in this data set that contains any other data type in these data types aside from the two. Right, pause the video and then work on the challenge. In some other situations, we might want to apply custom functions, multiple custom functions to our data frame, and we use the pipe method for that. So if we had this data set that we have here, we might want to clean the data as well as perform feature engineering. I won't go into what each of those two entail. Just this is just for just learning this concept. Our focus is just majorly on the concept for using the pipe function, so or pipe method. So here we have our first custom function called clean data and feature engineering. These two, we want to apply these two functions to the DF data frame. So we would use the pipe method and first of all apply that pipe method to the data frame, and inside that pipe method we pass the custom function. And we do the same thing for the second custom function. We apply another pipe method and we specify the function and we display the data frame. So let me run this and run the other code for that, and we get the final data frame that already has now the techniques defined here applied. Pause the video and then work on the challenge. Moving on, in some other situations, we might want to possibly perform or apply aggregate functions, multiple aggregate functions to a column. So for example, transaction amount, we might want to determine the minimum, maximum. So how do we do that? So how we do that is we use the aggregate function. We apply it to the data frame that we are working with. And then inside it, we specify inside the aggregate function, we specify a dictionary that contains a key value. The key would be the column of our interest, that's transaction amount. And the value for that particular key would be a Python list that contains the aggregate functions that we want to apply. And the output would actually be a table that contains the values, the respective values for the aggregate functions that we want, as well as just the column that's transaction amount. Pause the video and then work on the challenge. In some other situations, we might want to create more data, maybe for testing out our machine learning model to see whether it performs better. So that's feature engineering. So if we have this data set that we are going to display, we might have some transaction date as well as transaction time. If we wanted maybe to extract or get more data out of transaction date, then we can you can perform the following techniques. First of all, we would need to convert the transaction date column to have a date time format, which we do here using the toDateTime function. And then once we do that, we use the dt.year, dt.month, dt.day properties to be able to extract the year, month, and day components. And then we store those components individually in a separate column. So here we have a year column, month, and day column. Then we display the updated data frame with extracted date time components. Right, pause the video and then work on the challenge. In some other situation, we might want to use the lock method to just select data that might interest us. So if we have this data set and we wanted to, this is the data set that contains again credit card transactions. So if we wanted to maybe select card number, amount, and category, we can use the lock method as shown. We specify that we want to select all the records. We could specify the condition here, like want records greater than maybe having an amount 50. Then we could specify here, we could specify that, but here we just specifying that we want all the records, comma, then the column names passed in the Python list. Then we store the result in a variable called banking columns and display. Pause the video and then work on the challenge. In some other situations, we might want to count unique values in a column. So if we have this data set that of credit card transactions, and maybe wanted to answer a research problem, such as how many card types were there, within the transactions that we have, then we can use the nUnique function. We apply it to the column that we are interested in, that's the card type, and this should give us the number of unique items within the column itself. But if we wanted to get maybe the actual unique values, we can just say unique. You apply the unique function. All right, pause the video and then work on the challenge. Moving on, in some other situations, we might want to calculate some aggregate function, and also not calculate, we might want to apply an aggregate function to some grouped data and then rename that resulting column that we have. So in our case, if we have this data set that we have here, we might want to group the data by card number, and then later onwards apply an aggregate function such as the sum of amount as well as the mean of amount. But then again, at the same time, provide a name for those columns. Then we can use what are called named aggregation. So first of all, we define a dictionary that contains key value pairs. The first key value would contain the first column name that we want, and the respective and we define also a tuple that contains the first element as the column that we want to perform our aggregate function, and the second element in that tuple would be representative of the aggregate function that we want to perform on that column. So sum will be applied on the amount column, as well as mean will be applied on the amount column. We do the same thing for both columns. So these will be the new columns that we will have for the grouped data. So we'll have card number, total balance, and aggregate average transaction amount. And we just reset the index at the end. So if you display that, you should be able to see the output. All right, pause the video and then work on the challenge. Lastly, concatenating columns. So sometimes we might want to bring the values of two columns together and maybe define a separator. So for example, we might want to bring the values for card type as well as merchant name and have that as one column. So Visa dash Amazon, MasterCard dash Starbucks. How we concatenate those, bring those two columns together, which is concatenate. We would just define the column name, then we use an addition operator, then we specify our separator, which is still a string, then plus, then merchant name, that's the other column. And the result is stored in card merchant, which is a new column. And we preview the updated data set. All right, pause the video and then work on the challenge. So that's it with regards to this this session, this day 29 of the Pandas Library Challenge. We hope that you are able to find it valuable. And if you did, be sure to give this video a thumbs up. And if you'd want to be informed when we post such future learning experiences, be sure to subscribe. All the best in your learning journey. Bye-bye.